So the title of this lecture is Servo Motor Speed Control, where the controlling the speed of a servo motor. Introduction. Overview of the servo motor. Servo motor are rotary or linear actuator that allow for precise control of angular or linear position, velocity and acceleration. They are integral in applications requiring precise motion control such as robotics, CNC machinery and automated manufacturing. What is the importance of the speed control? Speed control in servo motors ensures smooth operation, accuracy and efficiency in various applications. So let's just see what is the basics of servo motor, the definition and the working principle. A servo motor integrates a motor, a position sensor like an encoder and a control circuit. It operates on a closed loop system where the control circuit receives feedback from the sensor to adjust the motor's motion accordingly. And what types of servo motors are there? The positional rotation servo, which rotates within a specified range like 0 degree to 180 degree. You can rotate till any degree. The second one is the continuous rotation. So rotate continuously in either directions like the clockwise or the counterclockwise. But what you are basically doing, you are controlling the speed by the input signal. So in these two types of servo motors, we can either control the position in terms of degree, and either we can control the speed in terms of continuity, like in either directions. Components. The first one is the motor. Provide the necessary torque, control circuit, so that process the input signal and feedback to control the motor. Feedback mechanism, typically a potentiometer or encoder that provides position feedback. So like you are giving the input, and here it is a summation circuits which can includes what types of error are there. If the output is not satisfied, then it fed back the signal to that place, and then it will calculate the error and give it to controller, where it sends signal to process, and then it will give you the output. So how servo motors are controlled, like you can use the pulse width modulations. So servo motors are controlled using pulse width signals. A typical control signal is a 50 Hz pulse, like 20 millisecond period, with the pulse width determining the position or the speed. Like if it is a 1 millisecond pulse, so the position is 0 degree, 1.5 millisecond pulse 90 degree position, and 2 millisecond pulse 180 degree position. So a servo motor is controlled by sending a series of pulses through the single signal line. The frequency of the control signal should be 50 Hz, or a pulse should occur every 20 milliseconds. The width of pulse determines the angular position of the servo, and these type of servo can usually rotate 180 degrees. They have a physical limits of the travel. Generally, pulses with the 1 millisecond duration corresponds to 0 degree position, 1.5 millisecond duration to 90 degree, and the 2 millisecond to 180 degree, though the minimum and maximum duration of the pulse can sometimes vary with the different brands, and they can be 0.5 milliseconds for 0 degree, 2.5 milliseconds for an 80 degree positions. Speed versus position control. So positional servos. Speed is indirectly controlled by the rate of change between position, and it is implementing delays between position commands can control the speed of rotation servos. So speed is directly controlled by the pulse width of the PWM signal. So pulse width around 1.5 milliseconds, and the pulse width less than 1.5 milliseconds cause rotation, but less than that. But the pulse width greater than 1.5 milliseconds cause rotation in the opposite direction, with speed increasing as the pulse width increases. Method for controlling speed. The coded based pulse width modulations. Like here you can see that gradually change the position in the small increments with delays to control the speeds. The external hardware or use motor drives or controllers that allow for speed adjustment, implement a feedback loop system like PID controllers for precise speed regulation using libraries like you can use the Arduino circuits that utilizes functions like servo dot write in combination with the delay to control the movement speed. So that's a basic circuit which controls the more speed of the motor, like you are giving the control signal to the pulse width to voltage converter, and then it compares what the position sensors output and what is the input, and it gives the error to the amplifier, and you will get the output to the motor and then to the load. So here is a basic simple code which can be used, like the code moves from 0 degree to 180 degree and with the 1 degree increments. Like this is the startup of the code, while loop, and then you can write the position like 0 degree, 1 what less than equals to 180 degree, and you are giving the increment of 1 degree with the delay of 20 milliseconds. So each steps, so this is a for loop and it will keep moving, so and the controlling the speed effectively of the movements. So advanced speed control is the PID controller, so implement proportional integral derivative controller to achieve the precise speed control by continuously calculating an error value and applying corrections, like we have seen previous circuits before. The feedback mechanism use encoders or tachometers to provide real-time speed feedback, allowing for dynamic adjustment. Like that is another is the PID controller that you are evaluating and then processing the if there is an error and then giving you the output. So what are the other challenges? Limitation in positional servos. Speed control is less direct and relies on timing between position commands. Jitter at low speeds. At very low speeds, servo may exhibit jitter due to the insufficient torque or signal resolution. Feedback accuracy. Inaccurate feedback can lead to error in speed control. Power supply stability. Voltage fluctuations can affect servo performance and speed consistency. And what are the applications? The first one is the robotics. Precise speed control enables smooth and accurate movements in robotics arm and mobile robots. Automation systems. Conveyor belts and assembly lines utilize speed controller servos for synchronized operations. Aerospace and defense. Servo motor control the speed of actuators in flight control system. And medical devices, equipment like surgical robots require precise speed control of delicate operations. So what is basically the summary? Controlling the speed of servo motor is essential for precision and efficiency in various applications. So methods range from simple coded-based approach to advanced feedback control system. What are the future improvements that can be done? Development of more sophisticated control algorithms and integration with AI for adaptive speed control.